this is Britt Caswell with another example video. In this video, I'm covering example 6 from section 3-5 in the SavvasRealize Algebra 2 textbook. So in this video, I'm looking at how to solve a polynomial inequality by graphing. I had put a typo and actually accidentally wrote equation, but we are dealing with inequalities in this video. So to start out, it says, what are the solutions of x cubed minus 16x is less than 0? So the first thing that we want to do in order to solve this by graphing is we need to put this in factored form so that we can actually graph it. Alright, so what I'm going to do is I'm actually going to start out by factoring out my greatest common factor here. So if you notice there's an x cubed and a 16x, so I can divide x out of both of those terms. So x cubed divided by x is x squared, and 16x divided by x is 16. Okay, I'm just going to put a note there. I factor out the GCF. So now I recognize with the x squared minus 16, I have a difference of squares. And so I'm going to use that difference of squares to break up that set of parentheses. So this turns into x plus 4 and x minus 4. So the zeros here, I'm going to take each of these and set them equal to 0. I have x equals 0, x plus 4 equals 0, so x is negative 4, and x minus 4 equals 0, so x is positive 4. And I'm going to go ahead and put those on our graph. So then what we need to do is we need to actually figure out like the end behavior here and draw our graph in. So I'm going to check out my x cubed here. So my coefficient is a positive 1. So that means that the right side goes up like this. And then my exponent is 3, so the left side is opposite. So it's going to go down. Now we learned in previous examples about multiplicity. All of these have a multiplicity of 1. So with that odd multiplicity, the graph passes through all of our zeros, which is how I know I'm going to end up with a polynomial that looks roughly like this. So now we're going to deal with the inequality portion of it. So what are the solutions where it's less than 0? So we're looking for all the x-axis, or all the values on the x-axis where the polynomial goes underneath 0. So my solutions are going to be this green part here, which is where x is less than negative 4. And then this green part here, where x is kind of sandwiched, right? X goes between 0 and 4. And it's not inclusive of those zeros because it doesn't equal 0 here. The inequality says where it's not equal to 0. So these are the solutions. So let's go ahead and try another one. Now you could, mind you could just graph these things on Desmos and see what comes out of it. I'm just trying to show you guys by hand in case it helps you in your future endeavors. So here, my greatest common factor, okay, is 2x. So I'm going to divide 2x out of all of this stuff. So 2x cubed divided by 2x is x squared. 12x squared divided by 2x is 6x. And 12x divided by 2x is 6. Now, this bad boy is not factorable. Okay? So, let's talk about what this graph is going to look like. So what I'm doing right now is I'm plugging it into Desmos to make sure I'm not lying to you guys. But while I'm doing that, I'm going to tell you guys, I know that this is going to cross through 0, right? Because I was able to factor that 2x out. But what's going to happen is the rest of this is probably going to have some kind of either imaginary solution, or it's not going to have whole number solutions. Alright, now when I put it in Desmos, I did get a graph that looks something like this. Alright, so here's the 0 that we saw. So we need to find these other two x's, and they're going to be real numbers, not imaginary. Okay, so let's go ahead and we're going to use the quadratic formula. And it's going to be real ugly, y'all. It's going to, you know, they approximate to decimals on Desmos. Alright, so my b value is 6, my a value is 1, and my c value is 6. So if I start to clean up, I have a negative 6, 2 times 1 is 2, and if I pull this radical to the side, 6 squared is 36, and then 4 times 6 is 24, times 1 is 24. So I'm looking at the square root of 12. Now 12 is 3 times 4, and 4 is 2 times 2. Now because I have a pair of 2's, that's going to come out, and I get 2 root 3 here. And then my last step here, I see 6, 2, and 2. Those have a greatest common factor of 2. So I'm just dividing the 2 out of the problem. So these are my other two zeros. Alright? That's what this and this are. And they're decimal approximations. So it's approximately negative 4.72 or 32 and approximately negative 1.268. Okay, that's what those zeros are. So if I'm trying to find the solution of this inequality, it says that it's where it's less than 0, so I need this part. Alright, now that's going to be where x is less than, when this is minus, so negative 3 minus root 3. And then I'm also looking for this part of the graph here, which is where x is sandwiched between 0 on the right, because that was a nice whole number, and negative 3 plus root 3. So these are the solutions of the inequality. Alright, so our last one, this one's nice and factorable, thank goodness. Missy loves herself some factorable stuff. So this one's a difference of squares. So it's going to split into a plus and a minus. And the square root of x squared is x, and the square root of 1 is 1. Now this one, I'm going to put this so that you guys know I did that later. Now this one, I could factor using the double bubble method. So that's because there's no number in front of x squared, so I'm going to put an x and an x. I drop down my first sign. And to get a negative 6, I have to have opposite signs, so this one needs to be a plus. And then what multiplies to make 6? That subtracts to make 1? Well, that would be 3 and 2. So that's not so bad at all. So if I go to graph this, which I'm going to sketch it out by hand, I have zeros at x equals negative 1 from here, x equals 1 here, x equals 3 here, and x equals negative 2 from here. And so I'm going to go ahead and put those on our graph right there. And so then all that we need to do is we need to pick a test point to see how this graph is going to happen. Each of these zeros has a multiplicity of 1, so it's going to pass through all of the zeros. And well, I like the number 0, so I'm going to use the test point of 0. Okay, so I could do it either at the top or the bottom. I'll do it here at the top. So I have 0 squared minus 1 times 0 squared minus 0 minus 6. So here I get negative 1, here I get negative 6, and negative 1 times negative 6 is a positive 6. So at 0, this graph definitely goes up. So I know here we have a bump like that. Now again, it passes through each of the zeros, so this passes through and has to turn around, and it passes through. And then here it passes through, turns around, and passes through. So we get like a weird kind of W-shaped graph. So now on this graph, we are looking where x is greater than 0, so we want this orange stuff. Or sorry, where the function's greater than 0. So I want this part here. Alright, so that's where x is less than negative 2. Oh, and my document's giving me some issues. Give me 1 second, please. There we go. So again, where x is less than negative 2 gets me that part. And then here, it's also above the x-axis, or above 0. So I know that I need to go from negative 1 to positive 1. And then here, it's above again, and that's where x is greater than 3. So these are our 3 solutions. So there we have it. That is how to solve a polynomial inequality. Until next time.